Okay, we're going to do something called the Pythagorean Theorem. It's really important in mathematics. It's like a fundamental thing, and you're going to use it a lot. I was taught that Pythagoras and his Greek mathematics group way back in Samos there a long time ago, 1,000 years BC or 500 years BC, that they came up with this idea of the theorem of Pythagoras, and well, that's the way we learned it in school. But it turns out that this was done maybe 1,000 years before in Babylonia, a long time before in India, and in China as well. They knew this relationship. They even had the proofs. So we call it Pythagoras, but it's an idea that has its roots in a lot of other cultures. Okay, anyways, here we go. I want you to start off. We're going to look at this triangle here, this green triangle in the middle of the page. Now, it's a special triangle. We call it a right angle triangle. Well, why is that? Well, I've got a little box here, and it's a square. And you may know that squares have the same angle in each one. All the sides are the same, this little red triangle, red square. It's 90 degrees in each side. I can show that it's 90 degrees. You're going to see, because if I put it up here, there's another 90. There's another 90. There's another 90. 4 times 90 is 360 around this point. So that's definitely 90 degrees. Well, this green triangle is called a 90-degree triangle. And it has a special property, a Pythagorean property. Now, watch this. If I were to make one side going down this side here, if I took this square and I made 4 units down this way, so that there's 1, 2, 3, 4, and then I made a square out of it on this side, you'd see the picture you see before you. What if I went down here and went 1, 2, 3, and then I made a square, 3 by 3, a square here? Well, something really special happens. It turns out, if I take that square and I go 1, 2, if you make a 4 square on this side and 3 square on this side, something special happens. If you've done that, if it's a right angle triangle, this side will be exactly 1, 2, 3, 4, 5 squares. So this side is called, is a 4 square side. This square on this side is 3 squared. And this side here is 5 squared. Well, something really special happens here. If you've got a right angle triangle, then something always happens the same way. And this is what happens. If you take the 2 small squares, 3 squared and 4 squared, if you add them together, you always get the long side squared. And it works every time for any right angle triangle. Let's see if we can even check it here. 3 times 3, there's 9 squares here. 4 times 4, there's 16. Well, 9 plus 16, that equals 5 by 5. That equals 25. So it works. Now, this is a famous right angle triangle, 3, 4, 5. The Egyptians used it to actually make sure they had a right angle. They'd measure 3, 4, and 5, and if they had a 3, 4, 5, they knew they had an exact right 90-degree triangle. Builders still use the Pythagorean triplet 3, 4, 5 to make sure they have a right angle. But it doesn't just work for the triangle 3, 4, and 5. It works for any 2 triangles. A and B are the sides next to the right angle. They will square. Those 2 small squares will equal the long side squared. And that's Pythagoras. And there it is, the Pythagorean theorem. If you've got a right angle triangle, the 2 small sides squared next to the right angle will equal the square of what we call the hypotenuse, the long side. Well, this is an introduction to Pythagoras. I hope it helped you. I hope it helps.